Let us apply the hypothesis testing for testing a claim about the population mean. In Pennsylvania, the average IQ score is 101.5. The variable is normally distributed and the population standard deviation is 15. A school superintendent claims that the students in her school district have a higher IQ than the average of 101.5. She selects a random sample of 30 students and finds the mean of the test score is 106.4. Tests the claim at significance level of 5%. So we know that the average IQ of the state of Pennsylvania is 101.5, but the superintendent believed that the IQ is higher than 101.5 and she wants to check. For that, she collects a sample of 30 students and finds that the score is 106.4. Now we see that 106.4 is higher than 101.5, but we need to determine whether this difference is because of randomness or it is indeed different from 101.5, which is believed to be the average score. So let's start with stating the hypothesis and identifying the claim. So hypothesis is, let's put it here. So we have H naught or H0 is, and let's say the mean we indicated by mu is equal to 101.5. Now this is what we know about the state of Pennsylvania. Now what will be the alternate hypothesis? H1 says greater than equal to 101.5, and this is what the school superintendent claims. We want to check whether it is indeed true or not. So we know the claim and we know the significance level alpha, and alpha is 0.05. We can compute the 1 minus alpha also. One minus alpha, which is our confidence level. I can just drag and put it here. Maybe I can put it here. Is equal to 1 minus 0.05. Now let's check what test we are going to apply here. The variable is normally distributed, the IQ variable. The sample size is greater than equal to 30, and we know the population standard deviation of the IQ score, which is 15. So we will be applying z-test. So let's determine the critical z value, z star. All right. So how much is g star? G star is the area under the normal curve at 95%. Since the claim is about greater than higher than 101.5, oh, this is an error. This should not be greater than equal to, it should be greater than. So G star will be the area under the normal curve until 95%. It will correspond to that value 1. So it will be norm dot standard inverse. What probability? 0.95. So 1.645 is the theoretical test statistic. Now we will compute the Z from the observed data. And check whether it is greater than 1.645 or less than that. So let's start with the sample mean, which is 106.4, the observed sample mean. The population mean, or the value that we have hypothesized, that is mu, mu is 101.5. And finally, let's copy it and change it to sigma. Which is 15. Now what is the formula for the Z? So let's put the formula of Z. Z equal to x bar minus mu divided by this will be root of n, and this is sigma. Right, so this is the formula that we are going to use to compute the test statistic. So Z observed is equal to, open the bracket, x bar minus mu divided by, open the bracket, sigma divided by square root of n. Okay, I haven't recorded n anywhere, so I will refer to here. Maybe I'll just kind of get the n first and then compute the value of Z. N is equal to 30. So is equal to x bar minus mu, close the bracket, that's the numerator. Denominator, open the bracket, sigma divided by square root of n, close the bracket for square root and close the bracket for denominator. So what we are observing is the Z value is 1.789. So as long as the value would have been between 0 and 1.645, it would have been considered to be an insignificant deviation from value of z, which corresponds to 101.5. Since the value is much greater than the threshold value of 1.645, we can conclude that the observed value of 106.4 is indeed statistically different from 101.5. So I can say, I can ask the question, is z greater than z star? Let's check what is the answer. Z greater than z star. True. The observed value of 106.4 corresponding to z star equal to 1.789 is indeed statistically higher than the null value of 1.5. So what is the inference? We have evidence in the sample to support the school superintendent's claim that IQ of her students is higher than 101.5. So we have found the evidence to support the superintendent's claim.